Hello, welcome to today's lesson. Today we are looking at the angle at the center theorem. Let's look at its wording. The wording of the theorem states that the angle which an arc of a circle subtends at the center is twice the angle it subtends at any point on the circumference of the circle. Now, before we can even analyze the weights, I just want you to know the tools that we are going to need to prove this theorem. We are going to need the knowledge of an isosceles triangle. Now remember, an isosceles triangle has two sides which are equal, and the opposite angles of those sides are also equal. So if these two sides are equal, remember this angle equals to that angle also. So we are going to need this info. And also we must remember that if a triangle has an exterior angle, let's say this is triangle ABC and we have exterior angle C1, then we need to remember that C1 equals to angle A plus angle B. So this is an exterior angle of a triangle, so equals the sum of the two interior opposite angles. Okay, back to our theorem. Now it says the angle which an arc of a circle subtends at the center is twice the angle it subtends at any point on the circumference of the circle. Right, it means we have a circle, we must have a circle, and we must have an arc. Right, so we have a circle, let's have a circle, and we have an arc. Let's say we have a circle with center O, and then we have arc AB. Now, this arc AB must subtend. To subtend is to lift off or carry, but then the reason why we use the word subtends instead of lifting or carrying is that normally we use lifting or carrying when we are carrying something upwards. So, but subtends, it can subtend it upwards, sideways, or downwards. Now, our arc AB is subtending the angle O at the center. Now, our theorem states that the angle which is subtended at the center. Now, we have that angle which is subtended at the center or carried at the center or lifted at the center. Now, we need to prove that that angle is twice or it is double the angle it. Now, this it means the same arc. So the same arc that is carrying the angle at the center must carry another angle at any point on the circumference. Okay, so meaning the same arc AB, which is carrying the angle at the center, which is angle O, must carry another angle at the circumference. So let's say it carries an angle there, and we can call the other angle, let's say C. Right, so I want us to look at three situations here. We have an arc AB again, which carries the angle at the center. Okay, here it is. We have arc AB carrying an angle at the center. Now let's put the point C here. Now the AB must carry again the angle C, so that we can look at the different situations there. Right, and then let's take another situation. We have our arc AB This is the arc AB is carrying an angle, but this time let's put the angle C here. But then if C is the angle there, it means our arc will be the bigger arc now. So this will be our angle. The angle at the center will be this one, and then it will carry this angle there. Right. So these are the three situations that talks about the same theorem. So in this case, we need to prove. Let's look at the required to prove. We are required to prove that angle AOB, the angle which is carried at the center or subtended at the center, it's twice angle C, the angle which is subtended at the circumference. Right. So now, as we have done with the previous theorems, then the first thing that we do is to do construction. Right. So with our construction, we are going to join CO and produce it. We join CO and produce it. Okay. So let's do that. We are joining CO and producing it. We can do it with all join CO and produce it, or we can join CO and produce it. Now as we do that, now we have divided our angle AOB into two, so we can say this is O1 and this is O2. Even the C is divided, is C1 and C2. So we have divided this now. Right. Even in this case, we now have O1 and O2, and then here we have O1 and O2, and then we also have C1 and C2. Right. So we also have C1 and C2. Right. So we are going to start proving. We have now done our construction, so let's prove. Right, like I said, we are going to analyze one triangle. If you check, we have two triangles in the first diagram, so we also have two triangles in diagram number 3. So let's say this is diagram 1, this is diagram 2, and this is diagram 3. Right, so we have two triangles. We are going to analyze one. Now let's look at triangle AOC. So let's look at triangle AOC. Now if we look at triangle AOC, we realize that OA and OC are a D. So let's put that statement down. It's very, very important. So OA equals to OC. Why? They are the radii of the circle. OA and OC. You can see this applies to all the three diagrams. Even in diagram number 2, OA and OC are radii. OA and OC are radii. So this is very, very important. Now, because OA and OC are radii, then it means our triangle AOC is an isosceles triangle because it has two sides which are equal. So as I have indicated that we need the knowledge of an isosceles triangle. So if AOC is an isosceles triangle, it means that C1 and angle A are equal. So we therefore conclude that angle A equals to angle C1. Angle A equals to angle C1 because they are the opposite angles of equal sides. Now, again, we know that O1 is an exterior angle of this triangle. If you look at O1 here, it's an exterior angle of our triangle AOC. Therefore, according to what we have learned, we can simply say that our angle O1 equals to angle A. Our angle O1 equals to angle A plus angle C1. Right, and we must give a reason. It's an exterior angle of a triangle. So O1 equals to, you can look at it in diagram number 1, O1 equals to angle A plus angle C1. Even in diagram number 2, O1 equals to angle A plus angle C1. Even in diagram number 3, same thing, O1 equals to angle A plus angle C1. So it's an exterior angle of a triangle. But remember, we have just said that angle A and angle C1 are equal. So if they are equal, then we can use them interchangeably. So we can decide to put another C1 on A because they are equal. So we can just replace the A with another C1 and say it's C1 plus C1, which is actually 2C1. Right, so in other words, angle O1 equals to 2C1. Right, so we have analyzed triangle number 1. So we are going to analyze triangle number 2, which is triangle OBC. Right, we are going to do everything that we did in triangle 1. I mean in the first triangle, yes. So we will be saying, remember we said that OC equals to OA. So in this triangle, we will say OC equals to OB. We give the same reason that there are D, and that it means in the first triangle we said C1 equals to A because they are the opposite angles of equal sides. And even in the triangle 2, we will say that C2 equals to angle B. Same reason, opposite angles of equal sides. Right, so, and then we continue to say O1 equals to C1 plus A. In this triangle, we'll say O2 equals to C2 plus B. Now, the same reason is because it's an exterior angle of a triangle. Right. Now, if we replace B with another C2, we will say O2 equals to 2C2. Now, mathematically, if we are going to repeat the same thing that we did there, we don't have to do it. So we can just use the word similarly. So, meaning, as we did with triangle 1, so is triangle 2. So we will say, similarly, angle O2 is twice angle C2. So as we did with the first triangle, so is the second triangle. Now, we are going to add the ones on the left. So we will say, if we add O1 plus O2, it will be the same as adding 2C1 plus 2C2. What we do on the left, we also do on the right. Right, we can even take out the common factor here, which is 2, and then we are left with C1 plus C2. Remember, these are angles. So now we have our O1 plus O2. So also these are our angles. Now, if we go back to the diagram, we look at O1 plus O2. So let's look at it. O1 plus O2, it's giving us our angle AOB. So we can replace O1 plus O2 with AOB. So let's do that. Instead of O1 plus O2, we will write our angle AOB So that's our angle AOB. Now let's look at C1 plus C2, C1 plus C2, C1 plus C2. So you can see it's giving us our angle C. So instead of C1 plus C2, we'll put our angle C. So we do that, and then this is 2, and then C1 plus C2, it's C. Right, so if we have done that, then we have proved our theorem. Remember, our required to prove, we wanted to prove that AOB is twice C. So that is the proof of the theorem. Now, this proof works on the way we have done it. Everything will work the same on diagram number 1 and diagram number 3. So, but it changes a little when we look at diagram number 2. So with diagram number 2, we are just going to work it out here. We will be looking at diagram number 2. Now, up till O1 equals to twice C1. Let's take it from there. We said that O1 is twice C1. We have seen how this came. Now, if we look at triangle OBC, we realize that OC equals to OB. Now this is these are the radii of the circle. So we know that the radii of a circle are equal. So OB equals to OC. So making this triangle OBC an isosceles. So it means therefore that the whole of angle C equals to angle B, because these are the opposite angles of equal sides. Let's not forget this reasoning. Now, if angle C equals to angle B, now we can come to the exterior angle. So if we check, O1 and O2 are forming an exterior angle of this triangle OBC. So we can simply say that O1 plus O2 equals to angle B plus angle C. This is an exterior angle of a triangle. Right. But then we just said angle B and angle C are equal. So the B and the C are equal. So we can replace the B with another C. So it means instead of B, we put another C. So we will say this is angle C plus angle C, which it's saying to us that O1 equals to, O1 plus O2 equals to 2 angle C. In other words, it's when we are talking about angle C, we are referring to angle C1 plus angle C2. So we can write it nicely as O1 plus O2 equals to twice angle C1 plus angle C2, but it's already, we know it's angle C. So if we look at O1 plus O2 in our diagram, if we look at O1 plus O2, so we realize that this, let's write it down. We said that O1 plus O2, angle O1 plus angle O2 equals to 2C1 plus 2C2. Right. So our statement that we have proved here is that angle O1 is 2C1. So in other words, this angle O1 here equals to 2C1. Therefore, we can conclude that the remaining angles are also equal. It means if this statement equals to this one and this first part equals to this first part. Therefore, we will conclude that O2 also equals to 2C2. Now, if we look at O2 now that we are talking about, O2 is our angle AOB. So we can replace O2 with angle AOB. That's our angle AOB. And then the C2, it's our original angle C. It's our original angle C that we were talking about. It's our angle C. So this one, it's okay, it's 2C. This one, it's our the way of proving this second diagram here. But the first diagram and the second diagram are the same. So in case they give you this first diagram, so you need to be careful on that one. It's a little complicated, but it's not that difficult. You can be able to do it. So thank you very much. Please don't forget to like, subscribe, and share. Thank you.